So in the last video we studied logarithmic functions, we were introduced to them. In this video we're going to look at some of the laws of logarithms. So some basic laws. The first one is that log base b of 1 is 0. So the log of 1, no matter what the base, is 0. Second, the log base b of b is equal to 1. And the third, log base b of m equals log base b of n if and only if m is equal to n. Now let m and n be any real numbers. Define little m to be log base b of m and little n to be log base b of n. This means that n is equal to b to the little m and n is equal to b to the little n. Right? This is by definition of the logarithm. Now, log base b of m times n would be log base b of b to the m times b to the n. By laws of exponents, this would be log base b of b to the m plus n. This is equal to m plus n. And then by our previous definitions, this is equal to log base b of big M plus log base b of big M. So this is what's known as the product law. And it states that for any real numbers m and n, log base b of m times n is log base b of m plus log base b of n. So if you take the log of a product of numbers, it is just the sum of the individual logs. And it is an easy and natural extension to consider the product of more than two real numbers. Again, we let m and n be any real numbers. Again, we'll define little m to be log base b of m and little n to be log base b of n. Now, log base b of m over n. This will become log base b of b to the m over b to the n, which will become log base b of b to the m minus n, which is m minus n. And then by the previous definitions, this is log base b of m minus log base b of n. So this is known as the quotient law. And it states that for any real numbers m and n, log base b of m over n is log base b of m minus log base b of n. So this says if you take the logarithm of a quotient of numbers, it is the difference of the individual logarithms. Once again, we let m be any real number. Now define log base b of m to equal x. So this would mean that m is equal to b to the x. Now, log base b of m to the n would equal log base b of b to the x all raised to the n, which would be log base b of b to the x times n. This is just simply x times n. And so we wind up with n times log base b of m. And this is known as the power law. So for any real numbers m and n, log base b of m to the n is n times log base b of m. So what this says is we can take the exponent of what we're taking the logarithm of and bring it down as a constant multiple. Right? So it's now that power times the log of the number n of the base. All right, so we're going to look at using these laws now. We're going to expand the following logarithms using the appropriate laws. So we start here with log base 3 of 30x all times 3x plus 4. So this is the product law. right? So we can write this as log base 3 of 30x plus log base 3 of 3x plus 4. Now we can apply product law again and write this as log base 3 of 30 plus log base 3x plus log base 3. And there's nothing we can do with the log of a sum, right? There's no property for that. So we just leave that. That's 3x plus 4. All right, so now we look at this one. So the first thing that we notice is we're going to use a quotient law. So we can write this as log base 3 of 15x times x minus 1 minus log base 3 of 3x plus 4 times 2 minus x. So product law would now give us log base 3 of 15 plus log base 3 of x plus log base 3 of x minus 1, then minus, and now product law on that piece, log base 3 of 3x plus 4 plus log base 3 of 2 minus x. And now just distributing that negative through. And this would be our expanded log. Now let's look at this one. So this is going to be a power law, right? So it says bring the power down as a constant multiple. So we'll have 5 times log base 2 of x, and there's no other simplifications we can make. Now in calculus, it is often advantageous to write complex logarithmic functions, a linear combination of simpler logarithmic functions. So for instance, this one. In calculus, it is more advantageous to write this log in this form. And so it is encouraged that you become comfortable with these laws now. Become comfortable with expanding a logarithm into a linear combination of logs. So we're going to do some more examples of that. So we'll look here. We're going to have ln of x to the 4th times y minus the ln of 7. So that is the quotient law. Now we can use product law and write this as ln of x to the 4th plus ln of y minus ln of 7. And now we can use the power law, and we have 4 ln of x plus ln of y minus ln of 7. And so now we have this one. Now this one isn't apparent straight away, but notice that we can write this as log of x to the 2/3 power. Right, so remember, if you have the nth root of x to the n, this is x to the n over m. Right, the numerator is what x is being raised to. The denominator is the index of the radical. And so now this is clearly a power law. So it's 2/3 Lx. All right, so now we look at this one. So let's first rewrite this as a square root of x minus 1 times 2x plus 1 squared, and then over, factor that as x plus 3 times x minus 3. Now we can use quotient. So we have log of the square root of x minus 1 times 2x plus 1 squared minus the log of x plus 3 times x minus 3. So for this term here, we can use the power law. So that is 1/2 times the log of x minus 1 times 2x plus 1 squared. Then on this term, we can use product law. And I'm also going to distribute that negative through at the same time. Now we can apply power law here. So 1/2 log of x minus 1 plus 1/2 log of 2x plus 1 squared. And then we still have these. And now we can apply the power law one more time to this term right here. So 1/2 log x minus 1 plus log of 2x plus 1, and then minus log of x plus 3 minus the log of x minus 3. Right, so that would be the expanded logarithm. Now, when we're solving equations that involve logarithms, we may need to apply these laws in quote-unquote reverse. That is, instead of expanding the logarithms, we wish to condense logarithms. So we'll condense this linear combination into a single logarithm. Well, the first thing is there are two power laws to use. We have this one here and we have this one here. So we'll have log base 2 of x squared plus log base 2 of the square root of x minus 1 minus log base 2 of x plus 3 squared to the third, which is x plus 3 to the 6th. Let's do a law next. So we have log base 2 of x squared times the square root of x minus 1. And now we have a quotient. And so we'll have log base 2 x squared times the square root of x minus 1 all over x plus 3 to the 6th. All right, so let's condense these logarithms into a single logarithm. So again, start off with the power. So I'll have log of x squared minus log of x plus 5 to the 4th plus log of 3x plus 5 to the 1 over x. Now remember, we can arrange these in any order. So let's take this term and this term as a product. So we'll have log x squared times 3x plus 5 to the 1 over x minus the log of x plus 5 to the 4th. And now we can use the quotient. Log of x squared times 3x plus 5 to the 1 over x all over x plus 5 to the 4th power. Now we're going to introduce the change of base formula. So most older calculator models only give the option for base 10 and base e for evaluating logarithms. So we need a way to evaluate logarithms of any base. Now, note that this discussion is now mostly useless, since most current model calculators can do logarithms of any base. Right? That was shown in the previous technology video. However, it does still have some importance when dealing with derivations in calculus, and so I will still go over it in this video. So let y be log base b of m. This implies that by would equal m. Then log base n of b to the y is equal to log base n of m. This means that y times log base n of b is equal to log base n of m. We can divide both sides, and we get y equal to log base n of m divided by log base n of b. Plugging back in y equals log base b of m, we get our change of base formula, which says for any real number m and any non-unitary positive real numbers b and n, log base b of m is equal to log base n of m over log base n of b. So what this formula is doing is it's changing the base of the logarithm from a base b to a base n. So what you do is you take the log of the new base of what you're taking the log of divided by the log of new base of the old base. Most commonly, we convert to base e. So this would become log base b of m is equal to the natural log of m over the natural log of b. Right, but again, this can be done. You can change any base to any other base you want. So evaluate log base 2 of 10 using the change of base formula. So what I'm going to do here is I'm just going to write out the change of base formula and then give you the approximation that the calculator would spit out. Again, refer to a previous technology video on how to use the calculator to find logs. I believe it was actually the previous video to this one in the list. So change of base, log base 2 of 10, of 10, we can change to any base. I'm changing to base e. So this would give us ln of 10 over ln of 2. And that would be approximately 3.3219. So those are the laws of logarithms. In the next video, we'll be looking at logarithmic equations. So equations involving both logs and exponential functions.